In Quechua, this is called Paqcha, a ceremonial fountain as a type of an altar that was used in ceremonies revolving around the cult of water.
Archaeological investigator Jonathan W. Alexander made a profound discovery while observing the wave patterns produced in the Paqcha ceremonial fountain at the Warawtambo archaeological site. Observing the surface of the water in the fountain, it can clearly be observed the phenomenon of what is referred to in physics as diffraction and interference. This observation led to the hypothesis that perhaps the fountain served as a kind of ripple tank in which the Inca could have observed wave phenomena similar to that of the double-slit experiment, in which a wave is split into two separate waves that later combine into a single wave. Changes in the path lengths of both waves result in a phase shift, creating an interference pattern as can be observed in the surface of the shallow pool of water in the fountain. The Huygens principle tells us that each part of the slits in the double-slit experiment can be thought of as an emitter of waves. The same can be considered with the fountain in relation to the multiple spill drippers that serve as the emitters. If the fountain were used as a ripple tank for the experiment of studying the interference of waves, the spill drippers can be used to produce, in this case, three coherent sources. Diffraction and interference are phenomena that can be observed not only in water waves, but also can occur in other types of waves, as was first demonstrated by the British polymath Thomas Young in 1801. His experiment indicated that light consists of waves, as the distribution of brightness can be explained by the alternately additive and subtractive interference of wave fronts. Interference of light is difficult to observe since the waves are so small and the vibrations so rapid. However, interference takes place with any kind of wave motion, and the effects of interference can be more easily seen by examining the behavior of water waves, which are in many ways similar to light waves, but travel more slowly and are more easily noticeable. Similar to what is observed with the interference pattern of light can also be observed in water waves. For example, if two droplets of water impact the surface in water at the same frequency, two sets of concentric circles are created that will interfere with each other as they travel across the surface. This is similar to the double-slit interference pattern for light, which consists of alternating bright and dark lines called fringes. The waves are said to be undergoing superposition, and the phenomenon produced is known as interference. The principle of superposition states that the resultant displacement at any point where two similar waves cross is equal to the sum of the separate displacements of the two waves. Wave interference occurs when waves that are traveling in opposite directions meet. The waves pass through each other, and this affects their amplitude. When two waves meet, their peaks and troughs can coincide, resulting in constructive or destructive interference. Constructive interference occurs when peaks overlap, doubling the wave amplitude. Destructive interference occurs when a peak overlaps with a trough, resulting in zero amplitude, causing them to cancel each other out. In constructive interference regions, wave action is greatest, while it's least in destructive interference regions. All these waves interfere to produce the diffraction pattern. This uniform pattern of ripples can be observed as shown in the diagram. The source of waves is coherent, which maintain at a constant phase difference and same frequency. Such a pattern of ripples is produced when water waves which are approaching each other meet and overlap. You can observe antinodal lines consisting of maximum peaks and maximum troughs. When constructive interference occurs, it's a line consisting entirely of antinodes, nodal lines consisting of points with zero displacement. When destructive interference occurs, it's a line consisting entirely of nodes. When you have two sources making circular waves, you get the interference of the two sources, resulting in symmetrical patterns spread out from the sources, producing line locations where constructive and destructive interference occur. When you put those two sources together, you get a complex pattern, and what is interesting is that there's an underlying mathematical relationship to this pattern, and physicists use this to make calculations to find things like the wavelength of light. Physicist Richard Feynman famously said, "The double-slit experiment is absolutely impossible to explain in any classical way and has in it the heart of quantum mechanics. In reality, it contains the only mystery." Feynman was also fond of saying, All of quantum mechanics can be gleaned from carefully thinking through the implications of this single experiment. This is an astonishing discovery, indicating that perhaps the Inca had a previous knowledge of wave phenomena and physics. As we already know and have seen throughout this series, the Inca possessed superior knowledge of tectonic architecture, hydraulic engineering and aqueducts, agriculture, spatial geometry, astronomy, mathematics and road systems, with bridges and other technological advancements that paralleled that of the Roman Empire.
This is natural spring water fed through underground aqueducts and mysteriously comes up through this hole here in this altar stone.
This video is just an excerpt from the full-feature documentary episode of Mystic Places, Magical Mystery Tour. Please click on the link under this video to view the complete documentary that contains a lot more that we're sure you won't want to miss. Also, please remember to click like under this video and subscribe to our channel by clicking the subscribe button.